Hello class, this is Mr. Chang with coming to you with 3.3 lesson homework examples, homework help. And I'll start with number 1. Okay, number 1, you're given the function y equals 1 over x plus 2 squared. And you're asked to find the point or points of discontinuity. For this one, the only thing that x cannot be under the real number system is negative 2. Because as you know, negative 2 for x will make the denominator equal to 0. And then what does this look like on the graph? Okay, let's take a look at this one. Okay, for number 1, you can see that x equals negative 2 is a vertical asymptote. Okay, from the left side of the negative 2 and right side of the negative 2, you see the infinite discontinuity. Okay, so that's the point of discontinuity. And then the type of discontinuity is infinite discontinuity. And then let's take a look at number 2 next. For number 2, you're given the equation y equals x plus 1 over x squared minus 4x plus 3. The denominator of this rational function, rational expression on the right side, is factorable. So you try to factor that first to see if it simplifies more with what you have on the numerator. So when you factor, fortunately or unfortunately, nothing cancels out. Okay, so this is what you have. Okay, this is what it is. As you can see then, x equals 3 and x equals 1 are going to be your vertical asymptotes. So these are the values that x cannot be. Okay, so these are the points. These are the x values of discontinuity. Once again, these are your vertical asymptotes. And then you could verify this with your graphing calculator or decimals. So generally speaking, okay, how do you know when something is a vertical asymptote? If you have restricted values on the denominator of a rational function, and if that's okay, if that factor doesn't simplify with what's on the numerator, then these are going to be your vertical asymptotes. Okay, x equals 3, x equals 1. If that x equals x minus 3, the factor x minus 3 happen to cancel with something on the top, then you do that, you cancel that out. I'll give you an example of that. And then let's take a look at an example of that. Okay, let's say you ended up with x minus 3 over x minus 3 times x plus 3. So in this case, even though x cannot be 3 or x cannot be negative 3, okay, we know that x equals 3 is just a whole. It's called a removable discontinuity. As opposed to x equals negative 3, which is a vertical asymptote. Even after simplifying, that expression x plus 3 remains on the denominator. Okay, so I want you to be able to predict what kind of points of discontinuity is a removable discontinuity as opposed to an infinite discontinuity.